All right, so if you want to add to the top of your note inside class kick, I would add what you needed to know for 2-1, which was obviously slope-intercept form. Y equals mx plus b, in which the m is the slope and 0b is the y-intercept. You want to know point slope just so that you can find the equation of a line if you're given points and slope. So y minus y1 equals m times x minus x1. And standard form or general form is ax plus by equals c. And from here we can get a shortcut to get slope, which is negative a over b. So if the equation's given to you in standard form, this shortcut for slope is negative a over b. We find slope from points by doing y2 minus y1 over x2 minus x1. Parallel lines have same slope. Perpendicular lines, let me actually spell out the word. Are opposite reciprocals, which means the sign changes and you flip it. And then, what else is in this section? Oh, vertical lines would be an x equals, there is no y, and slope is undefined. And horizontal lines are y equals with no x and slope equals 0. So it was a lot of little stuff in that section. So in these examples, I'm going to give you the equation. You're going to give me the slope and the y-intercept. I'm going to give you points. You're going to give me the equation. I'm going to give you a point and slope. You're going to give me equation. You're going to find something about parallel, perpendicular. All of that stuff was 2-1, okay? Any questions on the content? I'm going to let you work on this, and then we'll go over it. But any questions on the content in 2-1? The first one, I solved for y. If it was just slope, I would have just done negative a over b, but it also wanted the y-intercept. So I just put it in a slope-intercept form, and I got that the slope is 3/4, and the y-intercept is at -4, but it will be in coordinate points. Like, you'll see it. It's going to be multiple choice. So it will be at 0, -4. Be careful, don't pick -4, 0, right? If it's the y-intercept, the x is 0. So it's 0 and then the number. 0, -4. For the second one, you got to first find the slope. So you do y2 minus y1 over x2 minus x1, and you should have gotten -3/7. And then you can take that slope with either point and plug it in. If there's a point that's all positive, I would recommend grabbing that because people make silly mistakes when they're minusing a negative. But if you can't avoid it, you can't. You just grab whichever point. So I grabbed the second one, which was 5/2. I made it y minus 1 equals -3/7 times x minus 5 distributed. Come by my like terms, and I get y equals -3/7 x plus 22 over 7. And you can leave it like just like that. Again, it's multiple choice. It's not like it's going to be there once as that and once as a mixed number. It's only going to be there one way. The third one, it says it's parallel to x equals 5, which is a vertical line. If it has the same slope, technically they're both undefined, and you cannot plug in undefined. You'd have to know if it's a vertical line and it's parallel to it, it's also a vertical line, which means it's also an x equals, and then you just set it x equal to the x coordinate of that point. So it should be x equals 1. For 4, it says it's perpendicular. That slope, I got -a over b, which was 3/5. I flipped it and changed the sign, making it -5/3. And then I plugged that and this point in. So y minus the -3 became y plus 3 equals -5/3 times x minus 1. Distributed the -5/3 and then moved the 3 to the other side. And you got y equals -5/3 x minus 4/3. Questions? Okay, so that's 2-1, which is the whole first page of the quiz review PDF. Okay, then came 2-2, which is your function. So this is 2-2. And in functions, you had stuff like this. What value of x makes f of x equal 0? So how do I do this? Do I plug 0 in to the x? No. If the number's inside the parentheses, you plug it in. If it's equal to it, I literally change this to 0 equals 4x squared minus 25 over x plus 2. And then I'm going to solve for x. Then came 2-2. So this is find the values of x that make f of x equal to 0. We set it equal to 0. You can multiply by the denominator, but it is always going to cancel out. So if it's just finding the zeros, you can also just use your numerator. I can factor 4x squared minus 25 into 2x plus 5 and 2x minus 5, set them both equal to 0, and I get -5/2 and +5/2. For the third one, we are literally taking f of x and setting it equal to g of x. And then if you can, factor to solve, okay, which you're going to be able to. Then I get finding the values that make them equal, literally set them equal to each other. As soon as you see a squared and an unsquared, you know you're going to have to get everything to one side. So I moved everything to the left. I factored it. I get x minus 4 and x plus 2. Split and solve it, and you get +4 and -2. Still doing okay? Then we got domain. So this was still in 2-2. Domain from our equations. Remember, it's all real numbers. Or -infinity to positive infinity, because you're going to give it in interval notation, except when there's a variable in the denominator. For those we set not equal to 0. When there's a variable underneath the square root, for those we set greater than or equal to 0. And when there's a variable under the square root in the denominator, and for those we set it greater than 0 because it can no longer equal 0. So this is still in 2-2. All right, then came your domain, okay? Domain and zeros. So if I look at the first one, there is no variable in the denominator or under a square root, so my domain is not restricted. It is all real numbers, which in interval notation is negative infinity to positive infinity. To get the zeros, I set it equal to 0. I factored it x minus 5 and x plus 1, and then solve it, and you get positive 5 and negative 1. Questions on that one? No, it is all real numbers. The zeros are just where it crosses the x-axis, but they're still part of your domain. There's no restriction on that domain. So this is the domain by itself, and then this is the zeros.
What would be an example of, like, what would you have to do for the answer to be all real numbers except negative 1 and 5?
That would be if this was like 1 over that.
Okay.
Yep. And then those would no longer be zeros. They would just be restricted. Yeah. All right, B, your domain is positive 5 with a bracket on it to positive infinity. This time you had something underneath the square root, so we set that greater than or equal to 0. Solve, and you get x had to be greater than or equal to 5, which is where that interval notation comes from. To set it equal to 0 is how we find the 0. So we set it equal to 0, square both sides. You get x 0 equals 2x minus 10. Move the 10, divide by 2, and x equals 5 is your 0. Okay? Questions on that one? Yeah.
You don't really have to square root both sides. It's going to be 0 anyways. Can you stick
Right.
with this?
Yeah. Then C. Now there's two restrictions. There's a variable in the denominator, and there's a variable underneath the square root. So the denominator we set not equal to 0, and I get x cannot equal 5. The numerator, it's underneath the square root, so I would get x plus 2 is greater than or equal to 0, so x has to be greater than or equal to negative 2. So again, I would strongly recommend graphing it so that you can see what happens. The overlap would have looked like this. So I would have graphed it. Negative 2, positive 5. The top part, which is it's greater than or equal to negative 2, would be a bracket on the negative 2, pointing towards the right. And then the bottom is x cannot equal 5, which means it would be an open dot on that 5 or a parentheses on that 5. It can't equal it. So this is what that looks like in interval notation. Negative 2 to positive 5, bracket on the negative 2, parentheses on the 5, parentheses again on the 5 to positive infinity. So that's your domain. The 0, I would set just my numerator equal to 0 and then square both sides. You get 0 equals x plus 2, subtract the 2, and x equals negative 2 is the only 0. Still good? Yeah? Okay, for D, this is the tricky one because you've got a squared underneath a square root. So whatever's underneath my square root has to be greater than or equal to 0, which means I now have an inequality with a quadratic. These were on that last test, right? An inequality with a quadratic, we factor, we solve, and those are our test points on our number line. So I took x squared minus 9, I made it x plus 3 and x minus 3, which means negative 3 and positive 3 go on my number line. And then I pick a point from one of those ranges. I would recommend picking 0 if you can. I plugged in 0 into this inequality statement, which is what this is. And 0 minus 9 is negative 9. That is not greater than or equal to 0. So I know to rule out the middle and take the outsides, which is negative infinity to negative 3 with a bracket on negative 3. And then positive 3 to positive infinity with a bracket on the positive 3 and a parentheses on the infinity.
When you're plugging back in 0, do you plug it in without the square root, right?
You plug it in without the square root. Right, because the restriction is that x squared minus 9 has to be greater than or equal to 0. That's how we set it up to begin with, yeah. And then to find the zeros, I say 0 equals the square root of x squared minus 9, square both sides, the square root goes away, and then I know I have those same two zeros, negative 3 and positive 3.
When you get two answers, you set them both equals over.
Only if it's like a quadratic with an inequality. If it was just x squared minus 9 cannot equal 0, now it's that it can't equal 3 or negative 3. So like if it was this, 1 over x squared minus 9, then it's just that it can't equal negative 3 or positive 3, right? So it would be this, just open dots there. So it would be negative infinity to negative 3, then negative 3 to positive 3, then 3 to positive infinity. The only reason we have to test points is because you had a quadratic with an inequality. That's when you have to plug in a point and test it. Yeah.
A question on the quiz was like the rules if it's like if the x satisfies the y.
Oh, like where you're testing to see if it is a function?
Yeah.
No. On the test, maybe. Not on the quiz.
So none of the
If it's a function, correct. Yeah. There's more of those on the PDF. The domains are on there too. So for the piecewise function, you're going to get like f of x equals this, if this, f of x equals this, if this. And then you've got to take what's inside the parentheses, determine if it's in which set it's in, and then plug in from there. We know how to do these, right? Yeah? Okay. Okay, then came the piecewise function. So negative 2 is less than 0, which means I plug negative 2 in here. It would be negative 2 squared, which is 4. And then 0 is less than or equal to 0, so I'd plug it in here. 0 squared plus 2, which is just 2. Be careful. Those should be easy, right? Just don't mess it up. Don't plug it in the wrong one. And then came all the stuff in 2.3, which was your functions. So use the graph to find domain, right, which is our left to right. Range, which is bottom to top. Increasing is where it's rising as it moves from left to right. Decreasing where it's falling from left to right. Constant behavior for all of this, you give the x values.
If there's no point, it includes that number, right?
Yes, unless it's an open dot.
Okay.
Yeah, if it's an open dot.
It goes all the way up to.
So you're talking about the first one?
Yeah.
So my domain is going to be from, this is -1, -2, -3. So -4 with a bracket on it to -1. The range, the lowest point is -2. Gets a bracket because it's not an open dot. And it stops up here. That's just like a solid dot. So it goes to 2 and it gets a bracket. Yep. And then even, odd, or neither. So remember, even is if I plug in a -x and it goes back to the original. And that's symmetric to the y-axis. Odd is I plug in a -x and everything changes signs. And it would be symmetric to the origin. And then neither's just neither. Yep. Oh, I'm going to give you the equations for that one. Well, you'll see it with the equation form, but it would also be symmetric to the y-axis, symmetric to the origin. So y-axis would be I fold it left to right. This is not it. Origin would be like I could fold it diagonally in either direction. This is not it. Yep. And then evaluate at the indicated value would mean literally that this is my x, right? Find me the y that matches it. Yep.
How do you plug in -x?
That would, you'd have to have an equation. So if you're doing it from a graph, you're looking for symmetry. If you had an equation, which is on the PDF review part, I'll open that up. It's on the PDF. You plug in the -x, and if it's squared, it goes away. If it's absolute value, it goes away, right? Anything else is not going to go away. Yeah. All right, I'm going to let you. And then 2, 3, like I said, don't worry about the even and odd, okay? That will probably show up on your test, but it's not on the quiz. The -x and does it go back or does it all change? The rest is definitely on the quiz, okay? So the first one we did, the domain was -4 to positive, or to -1 with a bracket on both. The range, -2 to +2 with a bracket on both. And -4 is here, right? Or the x is -4 there, where my y is -2. This would be increasing on this first range here before it changes direction. And I use the x values. So -4 to -2 is increasing. Then it changes direction and it comes down, which is decreasing. So it's decreasing from -2 to -1. Remember, increasing and decreasing are always the x values, and they never get a bracket or a parentheses. The only time it would get a bracket parentheses if it like stopped constant. So if it ended like that, then this would be -1 to +1. The -1 doesn't get the parentheses because a parentheses can't be both decreasing, or a point can't be both decreasing and constant. It's just where it ends that it would get the bracket at +1. So if my graph did that, this would be the constant part. There's more practice on that too on the PDF. And then the second one, my domain, so from left to right would be 0. This is 1, 2, 3. This is 4 to 4, both solid dots. My range would be 0 because the lowest point to the highest point, which is 3, both solid dots. It is increase. Well, let's go left or right. This is decreasing. 0 to 1. Then it changes direction and goes increasing. 1 to 2. Changes direction and decreasing. 2 to 3. Changes direction, increasing. 3 to 4. This again would be neither even nor odd. And then to evaluate at f of 0, 0 is obviously here. Here's my coordinate point, and that is 3. This page is all 2-1, like you'll see it's loading right now. We're spinning. But the first page is all 2.1. The even solutions, there's actually no even on. The even are on this page. This is 2.2. The evens are all the way on the solutions part, but all the odds are going to be under Calc Chat. Just make sure you check the right section. And then this is the 2.3, and these are added on, so all the solutions are on the actual document that says solutions.